What's up everyone, it's Powell, and in this video we're going to talk about tangent lines. Now, a tangent line is a line that hits a circle in only one point. So for example, here I have circle D. That's not a straight line. Let's try that again. Good enough. I have circle D and I draw in line L. And it only hits the circle, so it intersects the circle at point C and C only. You can have lines that hit a circle twice, like that, but it's not a tangent line, it's actually called a secant line. But we're not talking about those today. A tangent line also has the distinction of being perpendicular to the radius or diameter of a circle. So here, radius DC is perpendicular to line L. And that makes for some interesting situations when you look at a circle network, which we'll look at a little bit later. But there's another property that it has, and this involves intersecting tangent lines. So here I have lines L and M that are tangent to circle D, and they intersect at point A. So you can have tangent lines that are parallel, but these ones are not parallel. Now I know that tangents L and M will be perpendicular to their respective radii. But I also know that line segments AC and AB are congruent. So tangent lines that intersect will make congruent line segments from their point of intersection to their respective tangent points. And since I also know that radii are congruent, all the radii of a circle are congruent, I've made a kite shape. So you can make a kite shape, and if I draw in line DA, I've made two right triangles. So you can do a lot of right triangle geometry in the circle as well. So this makes for some pretty interesting situations when we have a circle network like this. So here I defined angle Y, and I know that lines L and M are tangent to circle E, and I know that GS and LN are diameters. So therefore I know that NE and ES are radii. NEL is also a radius. So because line L is tangent to circle E, I know that angle ELT is right. So I drew that in there. I also know that angle SEL is 56 degrees. I know that because angle GEN and SEL are vertical angles. And as you can see, I've made a right triangle. Angle LET is a right triangle. And since LET is the right triangle, I know that angle Y and 56 and 90 add up to 180. So angle Y is 34 degrees. So with lines of tangency and points of tangency and radii, you can make right triangles, you can do right triangle trig, you can do, as long as you know the side lengths, you can do right triangle geometry and solve for angles of the network. And networks can get pretty complicated, so knowing these properties of tangent lines and other circle properties makes it a lot easier. If you like this video, please subscribe and share it with someone that you think might benefit from it. Thanks for watching.